Hello students, welcome to vlogger Mohit Kazim. Now today we will discuss a very important chapter of physics, that is magnetism and matter with respect to NEET. So first point we will discuss, that is magnetic dipole moment. Magnetic dipole moment can be also written as pole strength pole strength into overall length of magnet. Overall length of magnet is equal to L. Magnetic moment which is also equal to current into area of an magnet. So the unit of an magnetic moment can be written as ampere meter square. Remember, unit is very important. Next point, magnetic field due to dipole. Now, here now two important question can be framed. First question, what is magnetic field on an axis of an magnet? And next question can be, what is magnetic field on an equator? Magnetic field on an axis can be written as 2cm by r cube. It can be written as 2cm by r cube. Here c is your constant, which is equal to mu naught upon 4 pi, and here m is your magnetic moment, and here r is your distance from the center of the magnet to distance from the center of the magnet, and this r is on an axis of an magnet. This r is on axis of an magnet. Here dipole moment is pointing always towards north. Please remember, here dipole moment is always acting towards north. Magnetic field due to magnetic field on equatorial point, the formula is minus cm by r cube. Magnetic field which is equal to minus cm by r cube. Minus because dipole moment is toward this and magnetic field is both are in opposite direction, so it is minus, and this r is from the center and this is your equatorial point. Now torque. Next point is your about torque. Now torque on bar magnet is very simple, which is m cross b, and cross when we will solve, which is equal to mb sin theta. Now torque can be maximum when theta is over 90 degree, and torque can be minimum when theta is equal to 0 degree or 180 degree. Potential energy of an bar magnet, which is equal to minus m dot b. Now dot product, so here we can express it as mb cos theta. Now maximum it is m dot b when now potential energy is maximum when theta which is equal to 180 degree, because cos 180 degree is minus 1. So overall it can be plus m dot b. Now minimum, now it is minimum when theta is 0 degree, because it will remain as it is minus sign. Now, next very important point, that is time period. Time period of an oscillation. Time period of oscillation of magnetic dipole. So time period which is equal to 2 pi under root I upon m dot b. Here I is your moment of inertia, m magnetic moment, and b is your magnetic field. Gauss law and magnetism. Please remember, magnetic flux, that is b dot da, is always zero or even closed loop. This sign indicate that is closed loop, indicating closed loop. So here no monopole, so due to no monopole, magnetic flux is zero. Next point is about angle of dip. Now here angle of dip, very important here. Angle of dip only they will ask and basic formula, or it is of just value putting. That is angle of dip is your gamma. That is angle of dip is your gamma. So tan gamma which is equal to, so simple here, tan gamma which is equal to vertical magnetic field upon horizontal magnetic field. Vertical magnetic field upon horizontal magnetic field. Next, here horizontal magnetic field can be written as, so simple here, horizontal magnetic field can be written as a magnetic field of an earth cos theta, and vertical magnetic field can be also written as b sin gamma, and horizontal magnetic field can be written as b cos gamma. Now next, very important, that is diagram of an earth. Remember, now remember, for example, this is your earth. This is your geometric north. This is magnetic north. This is geometric south, and this is magnetic south. Here, the angle between geometric north and magnetic north is 11.3 degree. And this magnet is, for example, earth magnet itself, here a south pole and here an north pole. Remember that at the equatorial position, angle of dip is 0, and at pole angle of dip is 90 degree. It means at the equatorial position, angle of dip means here horizontal component is present. Here horizontal component is present, and at pole vertical component is present. Is present. So at equator, horizontal component is present, and at pole, vertical component is present. As we go from equator to, as we move from equator towards pole, angle of dip increases. That is positive angle of dip, and as we move for, that is for to upwards, and from downwards it is negative. Basic question will be, what is angle of dip at equatorial point? It is 0. What is angle of dip at pole? It is 90 degree. Basic question. Now, very important, apparent dip. Very important, apparent dip. Now what, when apparent dip will come? Now when geometric meridian and magnetic meridian means there will be, now this there will be some, now next the most important, now next the most important point is, that is of about apparent dip. So in apparent dip will come when there will be the angle of declination. That is when there will be angle in between geometric meridian and magnetic meridian. When there will be some angle between geometric meridian and magnetic meridian, that is alpha, which is also called as angle of declination, then there will be apparent dip. then there will be apparent dip. So apparent dip tan gamma dash can be written as BV, which is vertical component of magnetic field, that is this, upon horizontal component, which can be BH cos alpha. When we will take shadow here, so it will be BH cos alpha. So BH cos alpha. So tan gamma dash clear, which is equal to BV upon BH cos alpha. Alpha is which is your angle of declination, and two planes are at a right angle to each other. Then the formula will be cot square gamma 1 plus cot square gamma 2, which is equal to cot square gamma. Tangent galvanometer I, which is current, which can be k tan theta, means I is directly proportional to tan theta. I increases, deflection increases. Vibration magnetometer. Time, what is time period of vibration magnetometer? Time period, which is equal to 2 pi upon that is 2 pi under root I upon m into horizontal h. What is your h? H is your horizontal magnetic field. H is your, m is your magnetic moment, and h is your horizontal magnetic field. So important question will be, yeah, they will ask a relationship, as simple as that. So time period is inversely, that is inversely proportional to horizontal magnetic field. So T2 upon T1 can be regarded as under root H1 upon under root H2. Now there are total three properties of magnet, diamagnet, three properties of material, is it? So what is three property of material? Material can be diamagnetic, material can be paramagnetic, material can be ferromagnetic. Diamagnetic material means no dipole, and paramagnetic ferromagnetic means dipole is absolutely present. Now remember intensity. Now here formulas are very important. Here intensity I is your intensity of magnetization. I is your intensity of magnetization. I, which is equal to, here I have written I. Here I can be written as magnetization. Yeah, I is a intensity of magnetization. H is your magnetizing field. Yeah, magnetic intensity. So magnetization. So magnetization, which can be written as magnetic movement upon volume. So very important is, what is unit of magnetization? Ampere upon meter. Next point now, magnetic intensity. Magnetic intensity, intensity of magnetization, ampere per meter. Now how it is, so I will derive M, which is equal to current into area A. So here I into area A, here volume. So this you can write here, for example, meter square, meter cube, this cancel, ampere per meter. Magnetic field. Now remember, magnetic field, which is magnetic field in any Medium. So magnetic field in the medium can be written as mu naught in bracket h plus I. Mu naught in bracket h plus I. Here I is your, here intensity of magnetization, which can be also written as xi into h. So xi h. So magnetic field which is equal to mu naught h plus I. Xi is your susceptibility. So intensity of magnetization which is equal to xi into h. Xi which is equal to susceptibility. H is your magnetizing field. So absolute permeability can be, so absolute permeability can be also written as, absolute permeability can be also written as mu naught into b naught which is equal to mu naught into h. Magnetic permeability in any medium mu into h, and relative permeability can be now here, relative permeability can be written as permeability in medium upon permeability in area. Relative permeability which is also equal to 1 plus xi. Relative permeability can be also written as 1 plus xi. Relative permeability bm by mu naught. Now diamagnetism. No, what is diamagnetism? No atomic dipole. There is no atomic dipoles. Magnetic moment zero. Example can be bismuth, copper, gold, quartz, mercury, water, alcohol, air, hydrogen, etc. Now, most important point is of, the most important point, diamagnetism. So diamagnetic material is repelled by the poles. Intensity of magnetization, yeah, magnetization is negative. Intensity of magnetization is negative. Here susceptibility is very small, yeah, is susceptibility is very small, which is less than zero, slightly less dense. It moves from stronger field to weaker field. Whom diamagnetic material, who diamagnetic material moves from stronger to weaker, temperature independent, and relative permeability is less than 1. Relative permeability is less than 1, and relative permeability is, it is equal to 1 plus xi. So diamagnetism, no atomic dipole is present. Example is given. It is repelled by the pole. I is negative, slightly less dense, moves from stronger field to weaker field. Temperature independent. Relative permeability again less than 1. Paramagnetism, atomic dipole is not, magnetic dipole moment is not equal to 0. Example: aluminum, platinum, chromium, manganese, copper, sulfate. Weak, it is paramagnetic substances. Always remember, weakly attracted by the dipole. I is slightly positive. Susceptibility is positive. Susceptibility of aluminum is given slightly more dense. It moves from weaker field to stronger field. Relative permeability is positive, yeah, more than 1. Temperatures, now remember, paramagnetic material are temperature dependent. Here relationship can be written as susceptibility is inversely proportional to temperature T. This is your Curie's law. Now ferromagnetic substances, ferromagnetic substances, atomic dipoles. Example: iron, nickel, cobalt alloys. I intensity of magnetization is largely positive. Susceptibility is highly positive. Becomes highly dense. It moves quickly from weaker field to stronger field. Relative permeability is more positive. Relative permeability, which is also equal to 1 plus xi. Temperature, it is temperature dependent. Temperature is temperature dependent. Temperature increases, intensity of magnetization decreases, because most important relationship is about, that is Curie's law. The Curie's law states susceptibility is inversely proportional to temperature. As temperature increases, susceptibility decreases. When susceptibility decreases, ferromagnetic substances became paramagnetic substances. This is your Curie's law. Curie's temperature is
When
that temperature
susceptibility
when
decreases, ferromagnetic substances became paramagnetic substances. This is your Curie's law. Curie's temperature is that temperature when ferromagnetic substances become paramagnetic. So I think for today it is sufficient. Extra point, you can take a screenshot or you can note it. This is some extra point.